Word to cloud. Oh, yeah, it's just going to keep coming. All right. Well, we'll blaze on through. We are the Electronics Club, and this is our meeting on hobby electronics. Hobby electronics is different than kind of things you might do in your electrical engineering classes if you take those. This is much more geared towards making things. Excuse me. Making neat things and kind of building projects that we're interested in and that we can touch and kind of play with, essentially. We're not interested in like building advanced technical skills to put you on the cutting edge of the market. You'll find that through following your creativity and kind of making these projects, you gain those skills anyways. So might as well make it fun along the ways. This meeting is much different than our normal meetings. This is much more us talking at you, unfortunately. But we feel that this information is very, very important and gets you very far in our kind of structure here of what we're about. There's got to be a way to turn. There we go. Beautiful. You figured it out. Good job. Woo! I am an electrical engineer. This is so this is a little bit less hands-on than we usually do. Next meeting will hopefully be more hands-on. But there's a lot of really great information here, and this is a kind of broad picture of what we're about and what we do. So here, this is all our contact info. For general, just email electronicsosu@gmail.com. Our president is not here today. I am the vice president, Connor B. Height. Our treasurer ordered the pizza for us, but he has a class during this period. So cheers to Max. Our lab tech surveys our lab, make sure everything is nice and tidy. Chris, our webmaster, Jason, has COVID. Fun. Workshop coordinators, we have Mr. Matt, and then Siddharth. We have a Discord server. Many of you probably came in through the Discord server. If you haven't, check it out. We do office hours both by appointment. So if you email our general email, we can assign special hours. We're also doing it every other off week. So we have a meeting this week, and then next week will be office hours, which means that you can come into our club room and use all of our equipment, which we'll talk about more a little bit later. But definitely come to office hours if you're interested in working on your own project or doing things that we're going to talk about in this meeting. If you want to keep up with the slides and kind of work along here, this is definitely more important for like workshop meetings where you have like schematic and stuff. There is like one document that you might be interested in on how to troubleshoot a circuit, but that'll come a little bit later. But you can go to electronicsclub@osu.edu, and then there's a little slides tab at the very top. This is our attendance form. You can take a picture of it or go to the slides and kind of click on it. We really appreciate marking down attendance. Helps us get a lot of funding for pizza. We're allowed to have pizza, I'm pretty sure. Yeah. Okay. Yeah.
I've not received another email.
We're allowed to say pizza now instead of rectangles, as we used to refer to them as.
Edible cardboard.
Edible cardboard that we happened to bring. Everyone took home with them individually and separately wrapped packages.
Here in the room, and we just showed up and we're like, oh well, we can't let this go to waste.
Oh no!
You were afraid for a good reason.
I was afraid for a good reason.
See if I can fix it.
Yeah, see if you can copy a previous meeting. And while he's working on that, we're just going to keep going forward. I'm going to ask again a little bit later on, and hopefully you have the good heart.
I'll put another one like at the end of the slide.
Yeah.
If I can get it working.
We have some open officer positions. If you want to help manage our social media, that'd be greatly appreciated. We're looking for someone to help with funding and sponsorship, so kind of dealing with all of the money incoming to the club. And you can also just be like a general officer, which means that you help with workshops. You have a bunch of special access to the club room. So if you become an officer by emailing our previously mentioned electronics@osu or electronicsosu@gmail, You have special access to the club room at all hours. You get $200 for student funding for projects. There's a lot of really great perks that come with being an officer. Okay. So this is our content overview. We're going to be going into what exactly is hobby electronics, as I kind of mentioned a little bit earlier. How do I get into it? And most importantly, how much does it cost? The original title for this was Getting into Hobby Electronics Cheap, because we are college students. We don't have a whole lot of money. So we're interested in low budget get-ins to this hobby. So it's not like RF Club where you need like massive fundings into like these ham radios that cost like hundreds of dollars. We're trying to be as cheap and accessible as possible. No ham on the ham radio club. They're great people. I work with them all the time. But next, why the hell isn't it working? This is a nice troubleshooting guide that helps a lot of people. And we made it after last meeting, as you may have remembered if you were there, where we realized it would be very useful to have an explicit guide on how to troubleshoot a circuit. So this will be something that we go through and have a PDF for at the end here. And then electronics media. When you are getting into electronics, it's very good to surround yourself with media of it to kind of get further in. If you like golf, you watch golf videos, et cetera, et cetera. All right. How's the attendance? So we're going to subdivide the whole field of hobby electronics into three kind of large subgroups: beginner, intermediate, and advanced. So these are different price points, of course, and kind of different levels that you can get to. The thing we really want to emphasize is that when you use the Electronics Club resources, you can get from beginner all the way to advanced. So we have all of these really pricey equipments down in our club room. They're free to use. We have a bunch of components and stuff that you can use to build projects. So kind of broad overview. Beginner is stuff that we do here at the workshop. This would be like breadboard circuits, working with Arduinos. Raspberry Pis are very good for low budget projects. Intermediate is where we're actually soldering things to a permanent housing. We're interested in having like multimeters, tools that allow us to get a little bit further in. We want to get away from Arduinos and move to a dedicated microcontroller, which should be MCU, not MC. And then advanced, we're getting to like thousands of dollars or so. Is where we have these explicit oscilloscopes where we can look at signals, heavy duty components for driving big motors. We want an external power supply to actually focus things. And this would be also where we get these printed PCBs. As you can see, this pretty lights up here that we'll showcase a little bit later as well. So we're trying to get going from that breadboard to this like professional PCB. Okay. How's that attendance looking?
Oh, it should have updated the slides.
Okay.
I guess it doesn't because you're not in it.
Yeah. So if I go out and then back in, is it back on
I
the?
put it after the 3 levels.
Beautiful.
And I said I think it works now.
So I'm going to hand it over to Matt to talk about beginner level.
Like the shortened URL, I think.
Okay.
So I made the long one. And the QR code should work.
Is it working? Awesome.
Hooray.
So we're going to spend like just a couple minutes on this slide and
Yep.
then dive on forward.
Survey will be good because we're like down to half a piece already. Typically, we're begging people to take it home, so it's good. Okay. How much longer do we want to wait?
Just like a minute or so.
Okay. All right. So in the beginner category, you all are going to be probably pretty familiar with a lot of these. So we have stuff like the Arduino, ESP8266, which if you were here for last semester, I think we did a workshop on that. The Raspberry Pi, we did a workshop on. I think these are links to kits. So you'll get the Arduino and you'll get some separate components like resistors, LEDs, maybe a servo motor, stuff like that. So yeah, Arduino's really accessible. They've got great documentation. A lot of people are going to be really familiar with them because there's YouTube tutorials. The common thing is just a blinky, turn the light on, turn the light off. But it kind of gets you familiar with working with a microcontroller, working with hobby electronics, doing a little bit of coding, troubleshooting, that sort of thing. This is a picture of like what one of those kits might look like. So they give you a little breadboard, some 7 segments, some power, motors. So you can pretty much kind of get a feel for like, the ins and outs of digital and analog electronics. So, making a light up, making something move, taking inputs from the world and doing something meaningful with those. So like you could do, turn on like a traffic light sort of thing for how hot it is in your room, and then turn the servo motor on to open your door or something. The ESP8266 is kind of like the Arduino. It's Arduino-esque in that it takes some of, I think it uses the Arduino code, doesn't it?
It does.
It uses the Arduino IDE. But it's better for IoT or Internet of Things projects. So it's got onboard Wi-Fi and Bluetooth. So if you want to, log stuff to a server or tweet about it, hey, my room is hot, you can do it at the same time. So kind of the same sort of deal as an Arduino, but it has that added functionality. Raspberry Pi is nice too. It has a little more oomph than a microcontroller would. Basically, this is a full-on dedicated computer. So it runs an operating system like your computer would. So it has all the benefits and cons of that. So it's got more overhead to it. They're more expensive. They're a little harder to set up, but you can actually just get on it and use it to surf the web. You can watch YouTube videos on it. Probably a little more robust for your IoT stuff. You can actually run a server on it rather than just like connecting to something. But and it's got all the Linux terminal shell stuff you'd want. Another fun option is the Teensies. They have a big variety of them. This is one of their cheaper models, the LC, and it's a great alternative to the Arduino because it's got a Cortex M0, so it's 32-bit. Most of the Arduinos are 8-bit, so they're not going to have as many bits and 1 byte of memory. So they're faster, they're more powerful, their I/O is better. Basically, they're just a souped-up version of the Arduino. So if you're working on a project that needs that, you'll kind of figure that out at some point, and then you can go to these. These are about the same price, I think, but so if you need the feature set of this, it's pretty easy to go to. All right, and I'm going to turn it over to Connor, who's going to talk about the intermediate stuff.
Hello. So after we get really good experience with working with breadboard circuits, doing a bunch of Arduino projects, and if you look on the internet, there's just hundreds and hundreds of Arduino projects that you can do just straight out of the box. But now we're interested in having a kind of permanent housing to our projects. We don't want to have it hooked up to a USB to our computer anymore. We want to have this be an independent, work on itself kind of project. So when we dive into here, we need some more tools, namely a soldering iron. We want something called a perf board, which is essentially a breadboard, but we can solder to it and get all of our components onto it. Solid core wire, of course, we want to kind of wire everything up manually. We get into integrated microcontrollers. So instead of having the Arduino Uno that is attaching to our stuff, we're going to have these like tiny little DIP 8 ICs that we just plug in and controls everything for us. We need more tools here: multimeter, wire stripper, side cutter, things to do soldering and make sure that everything actually works, it functions as we want it to. And of course, battery holders and components as well. So now we actually want to buy like a bunch of resistors, have capacitors on hand, things like that. And of course, pretty lights, LEDs just everywhere. So soldering iron, you can buy these kits for pretty cheap on Amazon. I think it was around 17 or $18. This is the one that I have actually. It works very well. It hasn't broken yet. I had it for like 3 years so far. They're really good entry. We actually have a bunch of these. We bought a lot of these down in the club room. If you were here for our first meeting last semester, this is actually what we use. Something that is very important that no one talks about for some reason is Flux. Having a nice little jar of this, it's kind of like really hard face cream. You just kind of dip your soldering iron in it, and it helps the solder flow much easier. It's very useful to have around and to have on hand when we're doing soldering. Another big problem that we run into in workshops, if you've ever done anything in your classes, is solder can pool and get very difficult to remove. So we need things to remove them. This pump, I just kind of pump it down, heat the solder up, so it gets from hard to kind of liquidy. We just suck it up, and we can kind of re-solder our stuff. In a kind of different vein, we have these copper wicks that we can put on and heat up, and the solder kind of soaks into these wicks. So if we need to remove solder, this is how we do it. Helping hands, these are fun little clipper things. They hold your PCBs, so when you're working on them, you don't have to manually solder to a table, which often burns your table, or like whatever thing you're working on. So it's very useful for kind of getting a little bit more leverage on when we're soldering. Solder often has a lot of carcinogens in it, especially if you buy old solder that has lead in it. We don't want to breathe this stuff in, so we need to wear a mask. We need to make sure that we have some kind of fume extraction. So this can help put less carcinogens inside of your body. Cancer is bad. Don't get cancer. Moral of the day. You can also just solder in a well-ventilated area. Also useful. Just make sure you're not breathing the fumes directly in. So some very useful tools used for soldering and making sure that everything's connected correctly. Multimeters, of course, measure voltage, resistance. And the big one is we have a diode mode. When you press both of them together, it makes a beepy sound. This is used if you put it across a wire. It checks if it's a part of the same wire and connected together. This is extremely useful when you're soldering and not sure if two things are soldered correctly together. So that's the function I use all of the time. It's very, very useful, and getting used to that is very good. You can get really, really far in kind of making housings for things just by having cardboard, just some hot glue. That's how a lot of my projects are done. It's just by kind of getting creative with cardboard, hot glue, and box cutter. So we really don't need 3D printed stuff. At this level, we can just kind of cardboard stuff out. It's fast, cheap, and you can make really great projects with it.
You can also buy like little, they're like $5. They're little plastic ABS injection molded boxes you can drill a bunch of holes in and stuff. So if you want 3D printed, you can just buy one of those and cram stuff in there.
Yeah. So there's they're called like project boxes.
Yeah, like little. They come in all sorts of different sizes. So
yeah. So basically, we have these boxes, plastic boxes that you can screw down, put all of your electronics in. You can drill holes into it to get your inputs and outputs. So we're just interested in getting to a permanent housing where we can shove all of our circuitry into and kind of hide it. This makes it look much more professional, and we have a kind of cool project that we can say like, hey, look at this. Of course, multimeters must have, use wire cutters to cut things. For wires, you need to strip them. Usually just kind of clamp down and kind of twist out and pull. When we do another soldering workshop, you'll probably get more experience with that as well. So now we're interested in having an integrated IC. So we don't want to have an external Arduino that's controlling all of our stuff. We want everything to be inside of it. These are essentially internal Arduinos. This is the 18 mega, I think it's 328p, that larger IC there. And that's actually the same IC that is used to control the Arduino. So you can just put this directly into a project, kind of put some capacitors on it and have it work exactly as an Arduino does. We did a meeting on the Attiny 85 last semester. This is really, really good for doing a large swath of projects that just have very few input outputs. This is very powerful of how to miniaturize these kind of bulky Arduino projects. And you can see, I don't think we actually have like Arduino with us. So that's kind of the big bulky, and we get down to these tiny, tiny ICs. And we did a whole separate meeting on this before.
For instance, like the circuit that's on the oscilloscope that's making the plug logo, it's only 2 outputs and a ground. So that would work perfectly on an Attiny 85. You don't need an Uno or anything for that. Like it's just 2 outputs and that's it. So,
as a matter of fact, this is a little kind of where he at for my roommates. And this is running just off of a Attiny and a shift register, which I believe we also did a meeting on last semester. Just from last semester, you have all the things you need to make this very simple, but fairly useful kind of local project. It's a Velveeta box that I just kind of cut up and soldered a bunch of circuitry together here. This here is a little tone generator that I wrote a kind of music writer for. So this is running just off of an Attiny 85. I have a like little mounting putty that I put on the end of my guitar for it. And if anyone's into Dungeons and Dragons, I have a digital dice roller that's kind of stuffed into a dice box here. See if we're working. Awesome. Again, probably can't see super well, but you can select your kind of dice size and then roll it. So this is actually running off of the larger Mega 328p. So it has a bunch of very annoying kind of breakout boards there. But this is all accessible to the things that we've taught in this club and things that you can do. So the kind of thing we're driving at is that these intermediate kinds of projects are things that are accessible and things that you can think of and kind of do if you just have the kind of tools and know-how and use club resources. So yeah, that's the board. This was an online meeting before, so we could really show a lot of this off. Now that we're at this point, we want to have a bunch of components. So having resistors on hand, having capacitors on hand, very useful, having LEDs, just kind of outfitting yourself with very ubiquitous things. So sensors that you may have gotten from just previous project kits, we're now interested in kind of building it up. If you come to the eClub room, we have these kind of big boxes with like little pull-out shelves of a bunch of components, resistors, capacitors, et cetera, et cetera. The idea here also being not everything we want is in a kit. So we actually have to buy them from a different seller. I personally like Janeco. There's also DigiKey. Mauser.
Amazon isn't bad. You can get like assortment kits. Like you can buy like ceramic capacitors from a certain value to a certain value. Those are decent.
Yeah.
Probably actually easier to go that way if you're just trying to get an assortment to mess around with. Because if you go on DigiKey, you have to like 1/4 watt resistors of this size, and then you have to buy them in bulk, and it's kind of annoying. So But if you want to buy a lot of them, go to DigiGeek. You'll get a much better price on them.
Okay, Mr. Matt, I'll take it away for kind of getting into more advanced topics.
Okay. Yeah, so kind of in keeping with our theme of, making more permanent professional polished projects and stuff, moving from the breadboard to like something like VariBoard is great. If you want to take it up a notch, or if you're working with something that uses a certain kind of mounting style, which we'll talk about, you probably will want to look at doing a printed circuit board. So this is a printed circuit board. I don't know what it is. It looks like it's a small wearable. Maybe there's an antenna, but this is a little MCU. It's probably a Cortex something, but would work pretty similar to an Arduino. And so all of these little chip components here are going to be surface mount or SMD. Those are very, very tiny. I'll show off the tree here in a minute. That's all done with surface mount. You can do them with an iron if you have a very, yeah, what's up, Max?
Could you please speak up?
Yep. You can solder them with a soldering iron, but it's pretty challenging. So one of the best ways to do it is with hot air. It's just heated air blown at it. So we'll cover that in a minute. And then some of the different tools you might want to get into, an oscilloscope, a power supply, and a function generator can be helpful for designing and debugging more advanced circuits. So this is JLC PCB. They're one of a billion different fabricators of circuit boards out there. So you'll design it in a piece of software like this. I did a workshop last semester on KiCad. So you could watch that on YouTube if you wanted, or just come talk to me after. So you'll probably design it on a breadboard or on a VariBoard. You'll make a schematic in KiCad or EasyEDA or whatever, and make your board, and then you'll send it off, and then you can populate it with components. These are a small variety of different kind of SMD components. You all are probably used to through hole or THT. It actually goes through a hole in the physical mounting medium. These sit on top. So these little legs reach down and touch all these little metallized pads. So they're very tiny, but that's nice because you can cram a whole crap ton of them into a small space. You can get little booklets of samples. So like these might be like 15 or 20 capacitors per strip of these. So that's a decent way if you want to get into, especially if you're like repairing things that have surface mount components. Those are pretty handy, so you have a bunch of values on hand. This is what a hot air station looks like. So it's basically just a really souped up hair dryer, kind of. There's different tip sizes, so you can adjust how much airflow there is, and it has a variable temperature. So solder comes in two varieties. It comes in like a stringy form, and then there's also paste variety. So when you're soldering with hot air or on surface mount, you're going to use the paste because you can kind of squeeze it out onto the board. When they're actually assembling larger boards, they'll have these things called stencils, and they're just laser cut pieces of metal, or sometimes they're just polyamide tape. And you'll squeegee a bunch of solder on it, and it'll just put it on the pads. And then you use something called a reflow oven, and you'll populate all the parts. We would do it manually because I don't think any of us here can afford a pick and place machine. But if you can, let me know. I want to be friends with you. But industrially, it would be a pick and place machine, and it'll pick all the parts up and put them in the right spot. Then you put it in this oven and you just cook it, and it'll melt all the solder. That's almost critical for if you're going to do something like this. This is a BGA, ball grid array. They are a complete pain in the neck to do with hot air. Believe me, I've tried. You can also bodge them like this. That doesn't look like fun to me, but you can try that. These are really popular in like motherboards and things. Because if you think about how many pins are on here, trying to put all those around the perimeter of a chip, it'd have to be like this big. So you can squish them all down and just put them under it. It makes it harder to manufacture and repair, but you can fit more chip density, which is nice. So oscilloscopes are really nice for testing. They kind of you can kind of think of them about them as a multimeter. So this axis is voltage, and this axis is time. So multimeter is going to show you voltage at a specific instance. If you put it on a battery, it'll tell you 9 volts. If you put an oscilloscope on a battery, it'll show you a straight line right here. But you might actually have some ripple in your battery, or if you, in theory, don't do this, you put it on your outlet at home, you'll see a nice sine wave. So really handy for seeing moving, changing waveforms. If you're doing anything with serial protocols like SPI or I2C, this is really nice because a lot of times they'll even decode for you. It'll look at all the bytes and it'll tell you, hey, this is what the hex value is of this. Yeah, really, really handy. We have one in the club room. That's one over there. It's actually running in what's called XY mode, which is, it takes an X input and a Y input, and you can plot points on it. So that's an analog one. It has a cathode ray tube display, like an old school tube TV. So it's actually got a beam that it's steering, and it's like energizing the, it's releasing photons with the, yeah, anyway. That one's a digital one. If you're gonna buy one, that's probably the best one to buy because it's got all the math functions you'd ever want. But the project mode is just a little Arduino. It's basically just a vector or an array of 2 sets of numbers, an X and a Y position coordinate. And I just traced out what the Electronics Club plug logo looks like on a 0 to 255 X and Y. And it's just running through that over and over and over again. Oh, here we go. If you want to go to the GitHub repo, you can get the code. And there's a little guide on there on how to make your own logo. So if you'd like to come do that at the club sometime, you can make a logo and take a picture of it for your social media or something. All right. Vent power supplies are also really nice. When you're starting out, batteries or USB power are pretty much a good way to start because they're cheap and easily accessible. But bench power supplies are nice if you want high power, if you want some of the other features. They'll do current limiting, voltage limiting. A lot of times, depending on how nice a one you get, they're programmable. So you can tell it to only supply 9 volts and 100 milliamps so you don't burn up stuff. And they're plugged into the wall, so they don't die. They don't, like, you know, run out of power. Function generators are nice. They produce any kind of waveform you tell them to. So they'll make a sine wave. You can specify the frequency, the amplitude. You can do square waves. You can do ramp functions, all sorts of, depending on how nice a one you get, you can do other stuff too. And if you're going to be doing surface mount stuff, past certain sizes, you're going to need a microscope. So you can get one like this, or you can get really, really nice ones if you're doing like professional work. But it helps just because the joints are so small, it's helpful to be able to see. So you can inspect whether or not the joint is properly done or not. You can also get like little like plastic magnifiers, but and we have a 3D printing service. So we're talking about project enclosures. If you really want to spruce it up, you could do a custom one with like custom cutouts for your screens and displays and knobs and such things. And so I think you can just go on here and upload your 3D files. And it'll give you a quote or something, and you'll have your parts in a week or so.
And I believe we're the cheapest 3D printing service on campus.
I think that's probably right. And probably has the lowest lead time, because I'm friends with a few people who are in the ECE capstone right now, and you have to put your stuff in like 3 weeks in advance. So that kind of sucks. So I think, I don't know how long the turnaround for us is, but probably not that long. So, and we'll probably talk to you about it. Be like, hey, it's going to take a while. You might want to look at getting it printed somewhere else. You want to do this? Connor's going to do the troubleshooting part.
Yeah, kind of big picture. We've gone over breadboard circuits, how to get started, just these $30 Arduino kits. You play around with them. We kind of go through the pre-written programs for them. We learn how to do some of that Arduino code. Then we start wanting to get these independent projects that work on their own. So we cut out some cardboard, we solder stuff together with our soldering irons. We get these kind of nice independent projects, and then we're like, wow, I can make this professional. So we decide to order a professional PCB. We get it shipped to us from China. Comes within 1 week or multiple months. and we can solder them together, make these nice tiny components and have it be a very small chip. And we can have these 3D printed enclosures for them. So we can get from a Arduino kit all the way to this. Actually, I'll show off Matt's.
Oh yeah, I forgot to mention that.
Do you want
So this is what I did for the workshop last year. It started out as a breadboard project. It was this big. So this is a little themed holiday Christmas tree. There's a small bug in it, and it constantly plays the buzzer. But in theory, you're supposed to be able to touch the ornaments, and it plays a certain Christmas song. I just disabled that because it's annoying. But it's running a surface mount version of the Arduino that's on the Uno. And kind of how we were doing the stripped down version. This is a stripped down version of the Arduino. It's just got the bare basics to run this project. So it doesn't have a USB port. It doesn't have all this other stuff on it. But yeah, so it'll be up here if you want to come check it out or whatnot. They're pretty cheap. It's like maybe $30 for 10 of these shipped to your door. So it's not too bad.
And if money is a problem, you can
have
submit a form, which I think I should have a slide to a little bit later. But if you have a project idea in mind, you can fill out a project form and send it to the eClub email, and we can fund $100 of student projects. And if you're interested in becoming an officer, we can provide up to $200. So if you have a project idea in mind, if we've inspired you anywhere here, just kind of fill out that form and send it to us, and we can fund you and give you all of the components, as well as kind of materials that you need to make it. Okay, so diving into what the screen actually says now. Why the hell isn't it working? We come up to this a whole bunch if we actually get into real circuit design. So when you're working in your ECE class, if you've ever been in one with a lab component, you probably know some of this. But circuits never work the first time. They never work the second time, most of the times. So it's really good to have an explicit kind of guide on how to go through this. So we kind of drafted one a little bit earlier. We'll probably modify it a little bit later. But if you kind of click through this, we'll probably also post it in the Discord. This is a explicit guide on how to debug your circuit. Debugging is probably the most important skill that we can teach you here for any hobby electronics, because things will never work the first time. Part of this, why is it not working and what can I do with it? WTF is a data sheet. Data sheet is a very explicit, comprehensive PDF on how a particular component works. So this one is actually the one we did last meeting for the 555 timer. So this goes into the general description, every possible feature. It has schematics for all the possible use cases. So if you ever have a component and you want to know what it does or how to best work with it, always jump to the data sheet. If you're working with more complicated circuits, you often need the data sheet to see if the component is right for you, if it has the right power rating, if it has the right kind of outputs. So data sheets are used all the time. Okay, so like I mentioned earlier, if you're into the hobby, it's good to surround yourself with media in the hobby. So here's some of my personal favorites. Great Scott, he has a lot of tutorials on electronics basics. So like how a capacitor works, how to get into Arduino code, et cetera, et cetera. So if you're interested in diving into that, very, very good. Zach Friedman is just kind of wild. He has a lot of very creative projects that he does. He's very flamboyant about how he presents it. I think this is the guy with the Swedish accent. Andreas Spies. I'm not sure if that's the correct pronunciation, but he also has his own electronics basics course. He's very interested in very low power sensors. So there's something called LoRa, where you can have like this super, super low power sensor, have them on a farm like miles apart, and get data from that to this like central hub. So he has a lot of really, really great videos on that and other sensors. specifically for low power projects. Last year, we had a bunch of electronics team members submit their own YouTube channels that they liked. Electro Boom, a lot of fun. You've probably seen some of his videos sometimes. If you've been there,
I think most of these are from me.
probably a lot from that.
I would say the most educational ones are these two. Dave is great. He's very funny. He's Australian, so if you like accents, you'll love him. He does like basics videos. He does teardown videos and all sorts of stuff. He has more content than most people could even conceivably watch. And Alan is more in the RF side. So if you want to learn how test equipment works, he works with Tektronix. So if you want to learn how a scope works, he's probably the best on that. Or like Smith charts. Like any of you take ECU 3010, watch his video on Smith charts. It will help you so much. The other ones are also useful too, but those are my two favorites.
Yeah, so this is what I was mentioning earlier. You just need to go to the eClub webpage, actually. So I think it's electronicsclub.osu.edu. If you go kind of scroll down and to the left a little bit, you'll see your student project rules. So you just fill out your own form, just do it on a Microsoft Word and print off a PDF. And just email us at electronicsosu@gmail.com. It doesn't have to be complicated. Mine literally just said, I am an OSU member interested in getting funding for my project. The project proposal is attached. That's all you need. Just send it in and you can get up to $100 of funding. Very useful for getting anything you want done, created and made. So here's a kind of a list of different tools that are available at the eClub that we kind of mentioned throughout the meeting. Multimeter, oscilloscope, soldering iron, hot air rework station, power supply, function generators. We have this big box of integrated circuits. Use tubes right here. We actually have a website inventory where you can kind of look up a component and see if we have it, which is also found through the Electronics Club website. We have a bunch of different sensors and microcontrollers, which are found in these boxes. And if you're looking for something, you can also ask an officer, and they may be able to help. This is our kind of messy right now soldering iron station. Yeah, so we have a lot of tools down here. So come to our office hours next week. Email us if you're interested in working with anything there, or if you just want any help with a project or anything.
We could probably also do another tour. Last time we took some people down there. So if you want to see the room, we could probably take you guys down there tonight. I think, right, Connor?
Yeah,
Time.
we're kind of. This is a bit of a shorter meeting since we're not doing troubleshooting 30 circuits at the same time. So if anyone wants to stick around, and we can give you guys a tour of our club. This is my personal plug here. I really like this textbook. I bought it independently. I looked it up, and this is a really highly rated one called Practical Electronics for Inventors. So it goes over the kind of general theory on the first chapter, which is just stuff you do in your electronics courses, so electrical engineering. And then we get into like actual practical electronics and how to apply everything, which is the much more useful part. It goes into how to work with a bunch of different sensors, special use cases, et cetera, et cetera, et cetera. Okay, does anyone have any questions? I know we ran through a whole bunch of content here.
For project proposal, is there a number of meetings you have to attend?
Yes, I forgot to mention how being an active club member works. We usually have that kind of copied over from previous slides. So to be an active member, you have to have attended 2 or more meetings, I believe, in the same semester. So if you were here last meeting, it means that you are now an active member. If you scan the attendance sheet. So when you're an active member, then you can send that funding proposal as well. Being an active member gives you a couple of other perks as well. that I completely forget about now, but will remember by next meeting.
I think historically it's been like they get to use the parts and stuff.
Oh, yeah. In order to use the parts, you have to be an active member, sorry. Which just means coming to at least 2 meetings per semester, which is a pretty low bar in the grand scheme of things.
Can you just also talk about the meetings, like, can you attend a meeting in like an office hours the next week to be an active member?
Yeah, sure, we could probably allow that. We have office hours as well. We might implement, well, we recently implemented office hours, so we might make that a part of an attendance as well. So if you come to the office hour next week, which is in our little club room, that could also count. So you can be an active member just by next week. Does anyone else have any questions? Okay. Next meeting was run by Eddie. It's going to be on battery packs.
If anybody wants to talk shop about any stuff or sees, touch it, mess with it, you know,
Yeah.
you can come fiddle with the scope knobs or whatever. Talk about circuit boards. That's my favorite thing on the planet.
So that is our meeting. If you want to stick around, we'll be doing a kind of tour of our club room. You can also come up and kind of play with some of our projects that we've made. But thank everyone for coming out. Hope you enjoyed the pizza. There'll be a workshop next week. See you guys.